April 10th, 2019, 9 a.m. Eastern Standard Time, Washington, D.C. 6 simultaneous press conferences around the world. Brussels, Santiago, Shanghai, Tokyo, Taipei. Scientists are about to reveal something humanity has never seen. This, the first photograph of a black hole, M87 star, 55 million light-years away, 6.5 billion times the mass of our Sun. Look at it. That glowing ring? That's matter screaming as it dies, heated to billions of degrees, spinning at nearly the speed of light, about to fall into something that shouldn't exist. That darkness in the center? That's not empty space. That's not a shadow. That's a hole in reality itself, a place where physics goes to die, where time stops, where space breaks. And here's the part that should melt your brain. That monster, that cosmic nightmare, that thing that eats light itself, created the galaxy it lives in. Every galaxy in the universe, all 2 trillion of them, has one of these monsters at its heart, including ours. Right now, 26,000 light-years from where you're sitting, there's a black hole 4 million times the mass of the Sun. It's called Sagittarius A star, Sag star, the star that isn't a star, the darkness that births light. We've watched stars orbit it, we've seen it feed, we've heard it burp. Yes, black holes burp. X-ray burps that could sterilize solar systems. Nature's most violent monster has table manners that would embarrass a toddler. But here's the cosmic joke that nobody expected. Without black holes, galaxies wouldn't exist, stars wouldn't form properly, planets wouldn't coalesce, you wouldn't be here. The most destructive force in the universe is also the most creative. The ultimate predator is also the ultimate parent. The cosmic destroyer is the cosmic creator. A supermassive black hole is typically 0.001% of its galaxy's mass. That's like a grain of sand controlling a beach, a drop of water directing an ocean, a single cell commanding a human body. But it does. Through gravity? No. Through something far weirder. Through jets of matter that shoot out at 99.99% the speed of light. Through gravitational waves that ripple space-time itself. Through a cosmic dance that took us 100 years to even begin to understand. Einstein refused to believe black holes existed. He thought nature wouldn't allow something so absurd, so violent, so paradoxical. He was wrong. Nature doesn't just allow them. Nature requires them. In simulations of universes without black holes, galaxies don't form properly, stars burn wrong, chemistry breaks, life becomes impossible. Turns out the universe needs monsters in the basement to keep the lights on upstairs. Welcome to minutes of having your mind systematically destroyed and rebuilt by the most terrifying and beautiful objects in existence. Welcome to the story of how nothing creates everything.
Let's start with the basics. What is a black hole? The answer is simpler and more terrifying than you think. A black hole is what happens when gravity wins. Completely, absolutely, finally. Imagine space-time as a stretched rubber sheet. Put a bowling ball on it, that's a star. The sheet dips. That dip is gravity. Things roll toward the bowling ball. Now keep adding mass, more bowling balls. The dip gets deeper, steeper. At some point, you put so much weight in one spot that you punch through the sheet entirely. That hole? That's a black hole, a place where space-time isn't just curved, it's broken, torn, discontinued. The speed limit of reality. Everything has an escape velocity. Earth, 25,000 miles per hour, achievable with rockets. Jupiter, 134,000 miles per hour, harder but doable. The Sun, 1.4 million miles per hour, very difficult. White dwarf, 10 million miles per hour. Wait, that's less than before? Oh, right. I meant 190,000 miles per second. That's 60% the speed of light. To escape. Good luck with that. Black hole escape velocity, speed of light plus 1 mile per hour. But nothing can go faster than light. Nothing. Not matter, not energy, not information, not hope, not prayers, nothing. So, nothing escapes. Ever. The point of no return. Every mass has a Schwarzschild radius, the size it would need to be compressed to become a black hole. Earth, 9 millimeters, smaller than a marble. Sun, 3 kilometers, size of a small city. You, 10 to the minus 23 millimeters, smaller than smallest particle. Technically, you could become a black hole. You just need to be compressed to a size trillion times smaller than a proton. Weekend project. How to build a black hole. Don't try this at home. Step 1. Be a star 20 plus times the sun's mass. Step 2. Burn through all your nuclear fuel. Step 3. Run out of radiation pressure to fight gravity. Step 4. Collapse in less than a second. Step 5. Compress your core past the Schwarzschild radius. Step 6. Congratulations, you've broken physics. The collapse happens at 70,000 kilometers per second. That's 23% the speed of light. The core goes from the size of Earth to the size of Manhattan in less time than it takes you to blink. The rest of the star doesn't know what happened for several seconds. The core has already become a black hole while the surface is still shining normally. It's like your skeleton suddenly vanishing, but your skin not noticing for a few seconds, except instead of skin, it's a billion trillion tons of nuclear fire. The black hole family. Stellar black holes. Mass, 3 to 20 solar masses. Size, 10 to 60 kilometers across. How many? 100 million in Milky Way alone. Personality, angry teenagers. Intermediate black holes. Mass, 100 to 100,000 solar masses. Size, 300 to 300,000 kilometers across. How many? Maybe thousands. Personality, mysterious middle children. Supermassive black holes. Mass, millions to billions of solar masses. Size, millions to billions of kilometers across. How many? 1 per galaxy, at least. Personality, lazy gods. Primordial black holes. Mass, anything from asteroids to stars. Size, subatomic 2 kilometers. How many? Nobody knows. Personality, probably don't exist, but maybe dark matter? Black hole anatomy 101. The singularity, the center, maybe, probably not actually a point. Quantum mechanics says no, general relativity says yes. They fight, physics cries. The event horizon, the point of no return. Not a surface, just a boundary in space. Cross it and you're doomed. But you won't notice crossing it. You'll feel completely normal as you pass the point where escape becomes impossible. It's like crossing into New Jersey. You don't realize how bad it is until you try to leave. The photon sphere, 1.5 times the event horizon radius. Light orbits here. You could see the back of your head if you stood here. You can't stand here, you'd be dead, but theoretically. The innermost stable circular orbit, ICE-CO, 3 times the event horizon radius. Last stable orbit. Anything closer spirals in. This is where the death spiral begins. The accretion disk, the buffet line of doom. Matter waiting to die, heated to millions of degrees, screaming in X-rays.
Here's a mystery that broke astronomy for decades. Every single galaxy has a supermassive black hole at its center. Every single one. The Milky Way, Sagittarius A star, 4 million solar masses. Andromeda, 140 million solar masses. M87, 6.5 billion solar masses. NGC 4889, 21 billion solar masses. TON 618, 66 billion solar masses.
Ton 618's event horizon is bigger than our entire solar system. It could swallow our sun without noticing, like a blue whale eating a single plankton. Except the plankton is a star, and the whale is the absence of existence itself. The bizarre correlation. In 2000, astronomers discovered something that made no sense. The mass of a galaxy's central black hole is always 0.1% of the galaxy's bulge mass. Always! Tiny dwarf galaxy? Tiny black hole. Exactly 0.1%. Massive elliptical galaxy? Massive black hole. Exactly 0.1%. This is like finding out every house on Earth has a basement exactly 0.1% of the house's volume. Even houses built at different times, in different countries, by different species. Hey universe, why do all galaxies have the same black hole ratio? Universe, reasons. What reasons? Reasons! Which came first? Did galaxies form around black holes? Did black holes form inside galaxies? Did they form together? The answer is yes, all of it, simultaneously. It's complicated. The first black holes. The universe is 380,000 years old. First stars formed from pure hydrogen and helium. These aren't like modern stars. They're monsters, 100 to 1,000 times the sun's mass. They live fast, 2 million years max. They die hard, direct collapse to black holes. No supernova, no farewell tour, just star to black hole. These first black holes are 100 to 1,000 solar masses. Big, but not supermassive. How do you go from that to billions of solar masses? Option 1, eat everything. Problem? Not enough time. Even eating constantly, you can't grow that fast. Option 2, merge with other black holes. Problem? Still not fast enough. Option 3, direct collapse of gas clouds. Problem? Requires very specific conditions. Real answer? All of the above, plus something we don't understand yet. How did supermassive black holes form so quickly? Astrophysicists? Yes! That's not an answer. Astrophysicists, welcome to cosmology. Quasars, baby photos of monster black holes. 1963, astronomers discover quasi-stellar radio sources, quasars. They look like stars, but they're billions of light years away. To be visible at that distance, they must be outputting the energy of trillions of stars from a region smaller than our solar system. What could possibly produce that much energy? A supermassive black hole eating a galaxy's worth of matter. The accretion disk around an actively feeding supermassive black hole gets so hot it outshines the entire galaxy by a factor of 1,000. It's like a mosquito outshining the sun. If the mosquito was the size of a pinhead and made of pure nuclear fire and curved space-time into a pretzel. The feeding habits of cosmic monsters. Quasars, black holes eating multiple stars per year. Energy output, 10 to the 47 watts, more than all stars in the observable universe. Blazars, quasars pointed directly at us. Special attack, a relativistic jet to the face. Seyfert galaxies, black holes on a diet, eating maybe one Earth mass per year. Radio galaxies, black holes that won't shut up. Feature, jets longer than galaxies. Normal galaxies, black holes that are dormant. Like ours, occasionally snacks on a gas cloud. Our black hole is currently boring. It eats about one Earth mass every 3,000 years. That's like a human surviving on 1 grain of rice per year. But in 2013, we watched it eat a gas cloud called G2. It flared up, burped X-rays, then went back to sleep. Even cosmic monsters get midnight snacks.
Now here's where black holes get weird. Well, weirder. They don't just eat, they shoot. Some black holes launch jets of matter at 99.99% the speed of light that extend for millions of light years, longer than galaxies, longer than galaxy clusters. Hercules A, the jets are 1.5 million light years long. That's 15 times the diameter of the Milky Way, shot out by something the size of our solar system. It's like a grain of sand shooting water jets that reach from Earth to the Moon, except the sand is infinite density and the water is relativistic plasma. How to shoot jets from nothing? The black hole isn't shooting the jets, it can't. Nothing escapes, remember? The jets come from outside the event horizon. Here's how. Step 1. Black hole spins, up to 99.95% speed of light at equator. Step 2. Spinning drags spacetime, frame dragging. Step 3. Dragged spacetime twists magnetic field lines. Step 4. Twisted field lines act like a cosmic railgun. Step 5. Matter gets accelerated to near light speed. Step 6. Galaxy-sized death beam achieved. The Penrose process, stealing energy from the void. Roger Penrose discovered you can steal energy from a rotating black hole, not from inside it, from the ergosphere, a region outside the event horizon where spacetime itself is being dragged. Drop something into the ergosphere. Have it split in two. One part falls into the black hole, other part escapes with more energy than it started with. You've stolen rotational energy from the black hole itself. It's like pickpocketing the Grim Reaper. Theoretically possible, practically suicide, but the energy profit margins are incredible. The Blandford's-Nyack mechanism. The real way jets form. Magnetic field lines threading the ergosphere get twisted by rotation. They become springs, compressed springs of pure magnetic force. Power extracted, up to 10 to the 47 watts. Efficiency, 150%. You read that right. How? Stealing black hole's rotation. The black hole spins slower, jets shoot out faster. The monster feeds the galaxy by bleeding itself. What jets do to galaxies? Positive effects. Trigger star formation by compressing gas. Spread heavy elements throughout galaxy. Heat intergalactic medium, prevent gas from cooling too fast. Negative effects. Blow gas out of galaxies. Sterilize regions with radiation. Shut down star formation. Basically, death rays. The feedback loop. Galaxy grows, more stars form, more stars die. Black hole eats dead stars. Black hole grows, jets get stronger. Jets blow out gas. Star formation stops, galaxy stops growing, jets weaken, gas falls back, galaxy grows again. It's a thermostat, a 100 million year cycle thermostat made of gravity and death. The universe's climate control runs on murdered stars and violated physics. Very eco-friendly. Sagittarius A, the jet next door. Our nearest active galactic nucleus, only 13 million light-years away. Its jets are currently on. The jets, 1 million light-years long. Content, electrons, protons, some atoms. Speed, 50% speed of light. Temperature, 1 billion degrees. If those jets were pointed at us from 13 million light-years away, they would still sterilize Earth. Good news, they're not pointed at us. Bad news, they could be in a few million years. Worse news, we wouldn't know until the sterilization beam arrived. The life cycle of jets. Phase 1, black hole starts eating. Phase 2, accretion disk forms. Phase 3, magnetic fields organize. Phase 4, jets launch. Phase 5, jets drill through the galaxy. Phase 6, jets break out into intergalactic space. Phase 7, black hole runs out of food. Phase 8, jets shut off. Phase 9, cocoon of hot gas remains for millions of years. The ghost of the jet haunts the galaxy long after the black hole stops feeding.
February 11th, 2016. Scientists announced they've detected gravitational waves, ripples in space-time itself. The source? 2 black holes colliding 1.3 billion years ago. The signal lasted 0.2 seconds. In that fifth of a second, those 2 black holes released more energy than all the stars in the observable universe combined. Let me repeat that. 2 objects, the size of cities, released more energy than every star in the universe, in less time than a heartbeat. The merger dance.
Two black holes, 29 and 36 solar masses, orbiting each other. Starting separation, 1,000 kilometers. Orbital period, 1 second. Speed, 30,000 kilometers per second, 10% speed of light. As they spiral in, separation, 100 kilometers. Period, 0.01 seconds, 100 orbits per second. Speed, 150,000 kilometers per second, 50% speed of light. Final moment, separation, 0 kilometers. Speed, 200,000 kilometers per second, 67% speed of light. Result, merger. Two infinite densities becoming one infinite density. Math breaks, physicists cry, and the universe shrugs and continues. Space-time tsunami. The merger creates gravitational waves, actual ripples in the fabric of space and time. As the wave passes, space stretches and compresses. Time speeds up and slows down. Reality itself oscillates. The waves travel at the speed of light. They pass through everything. Nothing can stop them. Nothing can shield against them. How to detect the undetectable? LIGO, two 4-kilometer-long laser arms. Precision needed, 1/110,000th the width of a proton. That's like measuring the distance to Alpha Centauri to the width of a human hair. Two infinite densities becoming one infinite density? Math breaks, physicists cry, and the universe shrugs and continues. The discoveries keep coming. Since 2015, 90-plus gravitational wave detections. Black hole plus black hole, most common. Neutron star plus neutron star, kilonovae, create gold. Black hole plus neutron star, black hole wins. Biggest merger detected, 150 solar masses total. Smallest, 5 solar masses total. Furthest, 17 billion light-years away. When galaxies collide, Andromeda is heading toward us at 110 kilometers per second. Arrival time, 4.5 billion years. Our black hole, 4 million solar masses. Their black hole, 140 million solar masses. When they merge, gravitational waves visible to the naked eye as distortions. Final black hole, 144 million solar masses. Energy released, equivalent to annihilating the sun. Two infinite densities becoming one infinite density? Math breaks, physicists cry, and the universe shrugs and continues. The gravitational wave kick. When black holes merge asymmetrically, the gravitational waves are stronger in one direction. This kicks the final black hole. Kick velocities recorded up to 5,000 kilometers per second. That's fast enough to escape most galaxies. Yes, there are homeless black holes wandering intergalactic space. Invisible, unstoppable, could pass through our solar system, and we'd only know when planets started disappearing. Sleep tight knowing invisible cosmic monsters are wandering the universe at 1% the speed of light. They probably won't hit us, probably. The gravitational wave background. Recent discovery, the universe is humming with gravitational waves. Source? Millions of supermassive black hole mergers throughout cosmic history. The universe is literally vibrating from all the monster collisions. Space itself is ringing like a bell that's been struck continuously for 13 billion years. We're surfing on frozen gravitational tsunamis from battles between gods we'll never see.
Here's where black holes don't just bend physics. They break it completely. And physicists have been having nervous breakdowns about it for 50 years. 1974, Stephen Hawking discovers black holes evaporate. They emit radiation. They die. This should be good news. It's not. It's a catastrophe for physics. Hawking radiation. Black holes have a temperature. Quantum mechanics says empty space isn't empty. Particle pairs constantly pop into existence, then annihilate. Near event horizon, particle pair appears, one falls in, one escapes. Black hole loses mass. Temperature of black hole, inversely proportional to mass. Stellar black hole, 0.0000001 Kelvin. Supermassive black hole, 0.000000001 Kelvin. Microscopic black hole could be room temperature or higher. Big black holes are colder than space itself. They absorb more cosmic microwave background radiation than they emit. They're literally refrigerators. The evaporation timeline. 10 solar mass black hole, time to evaporate, 10 to the 67th years. Milky Way's black hole, time to evaporate, 10 to the 87th years. TON 618, time to evaporate, 10 to 100 years. The universe is 10 to the 10 years old. Black holes will outlive everything. Stars, planets, atoms, protons. When the universe is a cold, dead void, black holes will still be evaporating. Very, very, very slowly. The paradox that breaks physics. Quantum mechanics says information cannot be destroyed, ever. General relativity says black holes destroy everything, including information. Both can't be right. But both are right. Physics has a migraine. You throw a book into a black hole. The information in the book, every atom's position, every quantum state, falls in. The black hole evaporates. The radiation is random, contains no information. Where did the information go? Option 1, information is destroyed. Problem, breaks quantum mechanics. Option 2, information comes out in radiation. Problem, radiation is random. Option 3, information stays in remnant. Problem, infinitely dense remnants everywhere. Option 4, information goes to another universe. Problem, untestable and weird. The Firewall Paradox, 2012. New problem. If information comes out, the event horizon must be a wall of fire. But relativity says you shouldn't notice crossing the event horizon. Both can't be true. So, is the event horizon smooth or a firewall? Physicists, yes. That's contradictory. Physicists, crying. The holographic principle. Possible solution. Information isn't inside the black hole. It's encoded on the surface. The 2D surface contains all 3D information. This means reality might be a hologram. 3D space is an illusion. We might be 2D beings who think we're 3D. Congratulations, you might be a projection. Your entire existence could be painted on the surface of a space you can't perceive. But hey, at least the math works. Wormholes to the rescue. 2013, ER equals EPR conjecture. Einstein-Rosen bridges, wormholes, equal Einstein-Podolsky-Rosen pairs quantum entanglement. Every black hole might be connected to another black hole through a wormhole. Information isn't destroyed, it goes through the wormhole. Black holes as computers. Maximum information storage proportional to surface area, not volume. Stellar black hole, 10 to the 66 bits. Supermassive black hole, 10 to the 77 bits. Your laptop, 10 to the 13 bits. A black hole the size of a proton could store all human knowledge ever created. The ultimate hard drive is also the ultimate paper shredder. Very convenient, very annoying.
Now let's get to the beautiful paradox. These monsters, these reality-breaking nightmares, are cosmic gardeners. They create more than they destroy. A galaxy without a black hole. Computer simulations of galaxies without central black holes. Gas cools too fast. All gas turns to stars immediately. Stars burn out quickly. No second-generation stars. No heavy elements. No planets. No life. The galaxy burns bright and dies young, like a rock star on a terminal speed run. The thermostat effect. Black hole keeps galaxy in Goldilocks zone. Too much star formation, jets blow out gas. Too little, jets shut off, gas falls back. Repeat for billions of years. It's like having a violent babysitter who kills some of the children to keep the others healthy. How do we regulate star formation? Periodic genocide. That seems extreme. Welcome to astrophysics. Spreading the wealth. Supermassive black hole jets spread heavy elements throughout the galaxy. Iron from supernovae, gold from neutron star mergers, carbon, oxygen, silicon from stellar winds. Without jets, heavy elements stay in galactic center. With jets, they spread everywhere. Planets can form throughout galaxies. Life becomes possible in the suburbs. Reading the history. We can see black hole feeding events from billions of years ago. Bubbles of hot gas above and below galaxy, shells of compressed matter, cavities in intergalactic medium, each one a fossil of violence. The Milky Way has Fermi bubbles, 25,000 light-year tall structures above and below galactic center. Our black hole had a meal 6 million years ago. The burp is still visible. Cosmic archaeology. This crater indicates a feeding event. Translation: the monster was hungry here. Triggered star formation. Black hole jets don't just destroy, they create. Compress gas clouds, trigger gravitational collapse. New stars form. Some massive stars, they die, create new black holes. Circle of life and death. Different black holes, different galaxies. Spiral galaxies, smaller central black holes, ongoing star formation. Elliptical galaxies, massive central black holes, star formation stopped. Irregular galaxies, often no central black hole, chaotic star formation. The black hole determines galaxy personality. A small black hole equals active, young galaxy. A large black hole equals quiet, old galaxy. No black hole equals confused, messy galaxy. Galaxies are like people. The ones with bigger problems at their core tend to be quieter. The ones with no central issues are complete messes. The mysterious correlations. Black hole mass correlates with galaxy bulge mass, perfectly. Stellar velocity dispersion, perfectly. Number of globular clusters, weirdly well. Galaxy's dark matter halo. How? The black hole knows about dark matter it can't see or interact with. They grow together. Galaxy and black hole evolve as one system. Galaxy feeds black hole regulates galaxy. Both grow in lockstep for 13 billion years. It's the longest relationship in the universe. And like most long relationships, it involves periodic violence and long periods of silence. Let's talk about the black holes that make regular black holes look boring. The ones that shouldn't exist. The ones that make physicists question reality. TON 618, the Emperor of Darkness. Mass, 66 billion solar masses. Event horizon diameter, 400 billion kilometers. That's 2,600 AUs across. Our entire solar system is 100 AU across. This thing could swallow our solar system 26 times over, side by side. It's not a black hole. It's a black solar system, a black galaxy core, a black fuck you to human comprehension. Phoenix A, the impossible giant. Mass, 100 billion solar masses, theoretical maximum.
growth rate, 60 solar masses per year. Problem: shouldn't exist. At this size, radiation pressure should blow away infalling matter. It should stop growing. It doesn't. Primordial black holes, the maybe monsters. Formed first second after the Big Bang. Mass: anything from asteroids to stars. Evidence: none direct. Could be all dark matter. If they exist, asteroid mass ones are evaporating now. Moon mass ones are perfect dark matter candidates. Star mass ones look like regular black holes. Is dark matter just black holes? Maybe. Can we check? Not really. Why? They're invisible holes in invisible matter. Great. Microscopic black holes, the theoretical terrors. If extra dimensions exist, string theory, microscopic black holes could form in particle accelerators. Mass: few thousand protons. Size: smaller than proton. Lifetime: 10 to the minus 27 seconds. Danger: 0. They evaporate instantly. The LHC has been looking. No luck yet. Either extra dimensions don't exist, energy's still too low, or they're forming but we can't detect them. We're trying to create black holes on Earth. Is that safe? They'll evaporate instantly. You sure? The math says yes. The same math that can't reconcile quantum mechanics and relativity? Next question. Rotating black holes, the space blenders. Most black holes rotate, near maximum speed. Maximum rotation, horizon rotates at speed of light. Current record, 99.95% maximum. What happens at 100%? Nobody knows. Probably bad. Effects of rotation. Ergosphere forms. Frame dragging intensifies. Ring singularity, not point. And possible closed time-like curves. Time travel. Naked singularities, the forbidden fruit. If black holes rotate too fast or have too much charge, the event horizon disappears. The singularity becomes naked, visible to outside universe. Cosmic censorship hypothesis. Nature forbids naked singularities. Translation: the universe has a dress code. The universe literally prevents us from seeing infinity. It's cosmic censorship. The universe is rated PG-13. White holes, the theoretical opposites. Math says if black holes exist, white holes should too. Black holes, nothing escapes. White holes, nothing enters. Evidence? 0. They would spit out matter and energy, violate thermodynamics, be unstable, and probably explode immediately. Black holes are where matter goes to die. What about white holes? That's where matter goes to be born? Do they exist? Math says maybe, universe says LOL no. Living around black holes. Advanced civilizations might live near black holes for unlimited energy, Penrose process. Time dilation, live longer relative to universe. Waste disposal, ultimate garbage can. Computing power, maximum information density. Requirements: don't fall in, avoid jets, manage tides, manage radiation, and ignore existential dread. Let's build a civilization next to infinite gravity. Seems dangerous, but think of the energy savings.
Let's talk about the future, the far future, when black holes aren't just part of the universe, they are the universe. The next trillion years. 10 to the 12 years, last stars form. 10 to the 14 years, last stars die. 10 to the 15 years, galaxies dissolve. 10 to the 20 years, all protons decay, maybe. 10 to the 40 years, black holes dominate everything. For most of the universe's future, only black holes will exist. They'll be the only organized structures in an ocean of elementary particles. The black hole era. From 10 to the 40 to 10 to the 100 years, the universe is just black holes and radiation. Black holes slowly evaporate, universe slowly expands, temperature approaches absolute zero, nothing happens for Google years. The universe's final act is watching paint dry, except the paint is event horizons, and drying takes longer than everything that's ever happened multiplied by itself 1 trillion times. The final black hole. The largest black holes will be the last to die. Final black hole mass may be 10 to the 100 solar masses from eating everything. Evaporation time, 10 to the 106 years. Final temperature, 10 to the minus 30 Kelvin. Final moment, explosion equivalent to 1 billion nuclear bombs. The universe's last organized structure will die in violence. As it began, so it ends. The Dark Era. After 10 to the 106 years, no black holes, no structures, just elementary particles separated by distances larger than today's observable universe. Maximum entropy achieved, no energy gradients, no possibility of work, no possibility of life, no possibility of thought, heat death. The universe doesn't end with bang or whimper, it ends with nothing, forever. Have a great day. Unless quantum fluctuations could create new Big Bangs. Time, 10 to the 10 to the 10 to the 56 years. New universes could form, with new black holes, starting the cycle again. Penrose's cyclic universe. Roger Penrose suggests when universe reaches maximum entropy, it becomes indistinguishable from a Big Bang singularity. The end of one universe is the beginning of another. Black holes from the previous universe might leave signatures. We might be able to detect them. Some claim they have. So the universe is eternal? Maybe. And black holes are eternal? In a way. So they really do create everything? Possibly. That's not an answer. Welcome to cosmology. Back to now. But that's trillion years away. Right now, 100 million black holes in our galaxy, one supermassive monster at the center, dozens we can detect eating, thousands wandering invisible. They're creating stars, they're destroying planets, they're bending space, they're breaking time, they're making galaxies possible, they're making life possible. Every atom in your body heavier than hydrogen was forged in a star. That star was regulated by a black hole. That black hole determined where that star could form, how long it could live, where its ashes would spread. You exist because monsters exist. You think because nightmares dream. You live because death creates.
Look at it again. M87's black hole. That darkness surrounded by screaming light. That's not just a photograph. That's a mirror. It shows us the universe's fundamental truth. Creation and destruction are the same force. Life and death are dance partners. The void shapes existence. Every galaxy has a darkness at its heart that makes light possible. Every structure needs destruction to maintain itself. Every future requires forgetting the past. Every something comes from nothing. Black holes aren't just the most destructive force in the universe, they're the architects, the gardeners, the artists. They take chaos and give it structure. They take gas and give it purpose. They take death and give it meaning. Tonight, when you look up, remember, there's a monster at the heart of our galaxy. It's 4 million times the mass of our sun. It could destroy everything we've ever known, but it won't. It's too busy creating everything we'll ever be. The universe's biggest joke, the things that shouldn't exist, are the reason anything exists. The monsters are the mothers. The destroyers are the creators. And we're just starting to understand the punchline. Welcome to a universe where nothing creates everything, where darkness births light, where death enables life, where the most terrifying objects are the most necessary. Welcome to the cosmic paradox. Welcome to reality. If you enjoyed this video, remember to like and subscribe for more.